All right. So I've asked you to put your name and date on everything. We're doing trig values. And the definition of trigonometry, to me, it's the study of angles. It's just basically using angles. All right? You can read this fancy definition, relationship among the sides and angles, measures in triangles. Well, that's exactly the truth. We are going to start this with looking at triangles. And the triangle we're going to look at today are right triangles. These values only apply to right triangles. Okay? It's very important. And a trick, do you know what a ratio is? What's a ratio? Any ratio. Another name for ratio. In 7th grade, my 7th graders knew what a ratio was. It's another word for, say it again? Fraction. It's another name for fraction. And if you think about a fraction is a relationship between the numerator and the denominator. Okay? Well, your trig functions are all fractions. Your trig values, I should say. The trig function is actually a curve that we could graph. And we use that trig function. If I say y equals sine of x, you guys don't call it sin. Leave the sin at home. This is called sine. The actual function is sine, and we abbreviate it with the sin. And when we graph sine of x, which is later on, it looks like this. Well, I better do better. Somebody will yell at me online. Goes up, peaks, comes down, goes. And then what a trig function does, it continues. It does it again. It goes this way. It's a beautiful curve, okay? And so that's the function. But we're going to use the sine to talk about values that are on this curve. Values here, values here, values here. What are the y values that I'm plotting? And we're going to use our friend, the right triangle. Geometry did this with you guys. The beginning of this, thank you. The beginning of this ought to be, you should remember, because when I was teaching geometry here, we taught you how to find the sine of an angle, the cosine of an angle, and the tangent of an angle using a triangle. I don't know if your geometry teacher did all 6 of them. Did they? They may be better than I was. I don't know who taught it in the last couple of years. So anyway, Van Cleve, she loves geometry. She probably taught all of it. Anyway, guys, looking at this triangle, and I'm talking about this particular angle right here, we have opposite of this angle, and we call it opposite. We have sitting next to this angle, we call adjacent. We call the longest side on a right triangle, we call it the hypotenuse, which is across the street from the right angle. I would hope that your geometry teacher taught you about the famous Indian chief. There's a famous Indian chief who was looking at right triangles, and the Indian chief was named Sokotoa. Chief Sokotoa. Let me see if I get it right. Anybody see Sokotoa before? Yeah. What does it mean in English? For sine, it is? Opposite over hypotenuse. Who's talking? Me. Nice job, Ellis. Did you learn it here? Yeah. Who was your teacher? All right. And? Cosine is adjacent over hypotenuse. Cosine is this one. And the tangent is opposite over it. Adjacent over hypotenuse. And you said what? What is the T? What's the T stand for? Alice, you said S was sine, you said C stood for cosine, and T stood for what? Tangent. And we abbreviate it tangent. Tangent is opposite over adjacent. So this part should be a piece of cake because Alice just gave you all the answers. If you're looking at theta right here, you're looking at theta, sine will always be opposite over the hypotenuse. The cosine will always be adjacent over the hypotenuse. Right, Luciano?
Yeah.
What's tangent going to be?
I'm not paying attention.
Please move up here to this desk.
Yeah, I can.
Yeah. You can't be hiding back there. You just get off task. You're like looking out a window looking for squirrels. And I don't even have a window in here. Yeah, I care about you so much, I want to make sure that you're paying attention. This is day one of important stuff. And no. Where are you going? I want you close.
Okay.
I like you that much. The tangent, based on the picture, is opposite over adjacent. Now, did Miss Van Cleve talk to you about the cosecant and the secant and the cotangent?
No.
Those are called cofunctions. They're related to the function to the left. Sine is related to cosecant. They're related by the reciprocal. The reciprocal. The reciprocal. So whatever you wrote for sine, you will write hypotenuse over the opposite. Remember, the hypotenuse has a measure. The opposite side has a measure. It's a length. Could be feet, could be inches. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of the opposite over adjacent, so I go adjacent over the opposite. You need to memorize those, or remember Chief Sokotoa, who discovered this relationship. You know I'm lying, right? There was no Indian chief that did that. Now somebody's listening to it online and they're going to go, what? My teacher lied? Yep. Now, reciprocal functions. Remember I told you that these are reciprocal of each other? Hello? Remember I said that these were reciprocal? Yeah. Another way of doing cosecant is to take the sine and do 1 divided by sine of theta, in case you wanted to rewrite cosecant. Well, think about it. 1 divided by a fraction forces the fraction to flip. I mean, it's not that hard to see. Watch. If my fraction is 2/3, and the reciprocal we know is 3/2. But what if I do the math? 1 divided by 2/3 is equal to 1 times the reciprocal of the bottom, 3/2. I get 3/2. So you see why I wrote 1 divided by, what I write by? 1 divided by sine. Because 1 divided by sine will cause this to flip, giving you the same answer over here. Secant, 1 divided by cosine of theta. Cotangent, 1 divided by tangent of theta. You might be saying, well, why do I need to know those if I just know to flip? Later on, we're going to want to rewrite sines and cosines, or rewrite cosecants and rewrite secants. Most students don't want to work with secants and cosecants. Can I turn it into sine? Yes. Can I turn it into cosine? Yes. Because if you have it goes the other way around. If you have cosecant of theta and you don't want to use cosecant, you can flip it and call it 1 over sine of theta. If I can take sine of theta and make it 1 over cosecant of theta, it goes both ways, you see? That's why they're called reciprocal functions. Some books will call them identities, that they're the same. 1 over sine is the same as cosecant. 1 over cosecant is the same as sine. Sine is the same as 1 over cosecant. They're identities. You're going to see that word again. He's calling them reciprocal functions, and that's fine. Now, I have a triangle in front of you. Somebody was so nice enough that they measured all the sides. Here's a right triangle. They measured this to be 12. They measured this to be 5. And the hypotenuse they measured to be 13. By the way, this is called a Pythagorean Triple because 5 squared plus 12 squared is equal to 13 squared. I'm just saying. You've learned that Pythagorean theorem before, right? A squared plus B squared is C squared? Anybody? Yeah, okay. So the work's done for you. All I need to do is identify if my theta is here. If there's my theta, let's take a second. What would you call the length of the opposite side, please? Somebody tell me the length of the opposite side. Nice job. Who said that? Steffi did. The opposite length is called a 12. How did she do that? Well, she took the theta and she went across the street. What is the adjacent, Luciano, of that same angle? And he said, what angle is next to me? 5. Why did you not say 13? I'm just wondering.
It's not adjacent.
Why not? It's right next to me.
No, that's not. That's how it's.
Oh, what is it? Does that have a different name?
Hypotenuse. No.
Yes. Say it.
Hypotenuse.
We know for a fact that 13 has to be called the hypotenuse, so it cannot be called adjacent. Are you following what I'm saying? Hello? Are you okay? Francisco? So when I have those 3 numbers, I'm going to do one step that the author didn't do. Sine of theta, in my mind, is opposite over hypotenuse. And I did you a favor. I identified all 3 numbers. And since Steffi said the opposite was 12, and Luciano told us that the hypotenuse is 13, that's what I wrote over here, 13. There's your ratio. By the way, all sines and cosines, if you do the math, the calculator will always be between -1 and 1. Always a decimal, okay? So if I jump to cosine, and since Luciano told me it was adjacent, is and hypotenuse, he told me the adjacent was 5. That will also be over 13. Also less than 1. Now tangent is another animal. Tangent is going to be, we wrote opposite over the adjacent. That would have been Steph's number of 12 over Luciano's number of a 5. Notice 12 out of 5 is bigger than 1. Just saying. Now, I'm not going to think too hard for cosecant. Why? Why do you want to think hard? Just do the reciprocals. 13 out of 12. 13 out of 5. 5 out of 12. Okay, did I get lazy and not write the O's and the A's and the H's? I did.
Is that minus points though?
Pardon me?
Will you give us less credit if we don't write that?
No, because I didn't lie. I gave the truth. This is not really a requirement. It's a trick for you to help you make sure you get it right. For instance, was it required for us to write this out? Write this out. Write this out. Was that required by law? No. There's a lot of people who can look at that triangle and always know what the opposite of that angle is. What the hypotenuse will always be. what the adjacent of that angle is. I'm showing you because some people need the extra training wheels. All right? Let's do another try. Oh, by the way, what would happen, hypothetically, if I gave another angle over here, beta, and I'm talking about that? Would the answers change for sine of beta, cosine beta, tangent of beta? The answers would all change. Why? The opposite of beta is over here. The opposite of beta is a 5 now. You see how it changes? All right, so pay attention. Every angle has their own set of trig values. I should give you a trick question. How would I do the sine of this right angle? You can't, not right now. If I asked you what's the sine of the right angle, if I asked you what's the sine of 90 degrees, you'd have to have it memorized. It's a 1. Always. I'm just telling you, it's a 1. Who cares, right? But let's look at this one. Here's my angle. Here's my opposite. Here's my hypotenuse, always. So I'm going to write out my answer. 4 out of 8. Would you leave that with a respectable? No, it's not 8. Ooh.
No.
Yes, listen to him.
Explain.
She's fast.
Because the right angle is...
Oh my God! I didn't think anybody was paying attention.
Oh.
You were gonna beat her to the punch. All right, Alice, you got to say it out loud because Luciano was gonna argue with you.
No, I see it now, sir, because the right angle and the adjacent, or no, not the adjacent, but the
Keep going.
hypotenuse is 4.
How do you know?
Because it's,
Well, the hypotenuse is not 4.
no, but it's 4.
Yes. How do you know though? How do you know?
Because the adjacent will always be at the bottom of the...
Nope.
Nope.
I need a better definition.
Across to the other side.
The right angle.
Uh-huh.
You go across.
Across the right angle. So it's 4 over 4. Wait, I gotta write it. Let me erase it all. I'm glad you played devil's advocate though, Luciano. Whoop, why did I erase that for? Opposite over hypotenuse. Okay, what's the opposite of my theta?
4.
4. What is the true hypotenuse?
4 versus square root of 5.
And is there anything you could do to make that look simpler? What could I do to that fraction?
Square root of 5 and then multiply it.
You know what? You're making a good point. First of all, let me first get rid of the 4s, can I? Don't they cancel out? Doesn't that turn into 1 over square root of 5? I'm okay with that answer, but I guarantee you the author says, don't leave a square root in the denominator. So I'm going to do what Luciano said. Is there a name for that where you multiply by square root of 5 over square root of 5?
That I know.
It's called rationalize the denominator. 1 times square root of 5 is square root of 5. And square root of 5 times square root of 5 is how much? 5. This would be the answer that we'll be expecting. While I'm at it, can you tell me what the answer will be for cosecant?
So 5 over square root of 5.
Steph, you're exactly right. 5 over the square root of 5. I'm going to write that down. Please don't write it down. I'm going to write it down, but I want to ask you a question. What would I have to do now to record the correct answer? I'd have to rationalize it. I got a secret. What if we flip the answer before I rationalize the other one? Yeah, say it again.
It's just going to be square root of 5.
It would be just square root of 5. Yes. She's flipping this one right here. Now, you don't have to listen to me. You could rationalize. That's fine. But I'm lazy. Okay? All All right, cosine of that theta. Cosine would be A over H. A is how much?
8.
8 over 4 square roots of 5. And when I rationalize it, it turns into, what is 8 times square root of 5? 8 square roots of 5. And then I got a 4 times square root of 5, square root of 5. Doesn't that cancel out the square root? 4 times 5? Wouldn't it have been better to have canceled out the 4 with that 8 before I did that work? Probably. Nobody ever said yes.
Can you just keep the answer at like 8 over 4 square root of 5?
I'm going to tell you that the professional answer is no. Not that it's wrong. And it's in AP calculus, it's perfect. We leave it. But we need to always think about stepping up. Would I count it all wrong? No. Would I take off a point or two? Maybe. Because I want you to be the best that you can be. So, back to what I was saying about the 8 and the 4. If you reduce before you do the work, where's it at? Why is it making my screen look like that? Where am I at? It didn't even do the moving. Keeps doing. Oh, I have to just erase it. And something's coming up there. It wants me to take a picture. I don't know why. This icon, I don't know if you can see it. Anyway, what did I have written there that I just erased?
No idea.
Oh, it did take a picture. Oh, look at that. It tore that off. Why did it do that? That's weird. You can't see it, maybe. All right. Oh, there it's back again. I wanted to erase this. There it is. How could I simplify first? Could I not just, before I do any work, is say 4 goes into 4. I know Steffi doesn't want to do this either. 1 time, 4 goes into 8 twice. That becomes 2 over the square root of 5. And when I rationalize it, if you get really good, you don't have to show the square root of 5 over square root of 5. You can literally just say 2 square roots of 5 over 5. What would secant be? And which of those would I flip? Pardon me? Oh, it froze. Let me save mine and I'll go back. Okay, back to business. Sorry for... If I'm doing secant, which fraction would I want to flip? Do I want to flip my answer? Do I want to flip the this one? I'd flip this one. Square root of 5 over 2. If you flip this one, then you're going to do some more work. All right, moving on. 2 more to go. I'm crooked today. Tangent. Opposite over adjacent. Opposite is what? 4 over. Somebody tell me what's adjacent.
Horizontal is
8. Thank you. The legs are always going to be opposites and adjacents. Always. Always pay attention to the legs. And that reduces to what? Half. And then if I flip a half, it turns into what? 2. Let's do one more on this page. All right. Uh-oh. Sine is opposite over hypotenuse. What do you notice, Luciano?
That.
What are you looking at, Luciano?
My phone, sir.
Put it away, Luciano. Did I write you up the last time?
Yeah.
I didn't. No, the last time?
You did.
I did?
I got
Yeah,
ISS.
find the opposite.
You want to go again?
Nope.
Yes, you do.
What's it?
I used to tell my mother that every time I do this, it hurts. My mom would say, quit doing that. So if you don't like ISS, quit doing it. Opposite over hypotenuse. What's my opposite?
You have to find.
Nothing. I have to what? That's not fair. Like I have nothing else to do in my life, right? So I'm going to label it. If it's not there, Steph said it's nothing, but it is really there. I'll call it OP. That way it stands out as or I'll call it OPP. How do I find it? Yes, you do. It's opposite, whatever that is, squared, plus 20 squared has to be 29 squared.
What's 29 squared?
I don't know. I don't have a calculator.
I don't have a calculator.
So opposite squared, I don't know yet. What's 20 squared? Somebody fast in your head.
400.
Thank you, Steph. Plus 400. And I would love to tell you that I could do 29 squared in my head, but I can't. Alice has a calculator.
41.
Oh, how much?
841.
Oh, 841. I thought you said 41. All right, how do I finish solving? Take away the 400 from both sides. The opposite squared is, somebody, 841 minus 400. 441. How do I get rid of the square on the word opposite? Do I need plus or minus? No. We don't. Opposite is how much? 21. So I'll go back over here and I'm going to write 21 here. The shortcut. If you're listening, this will save you some work. You could literally pick up your calculator and say 29 squared minus 20 squared, take the square root. You literally can do that. 29 squared minus 220 squared with your calculator, take the square root. And that gave us 21. All right, moving on. Opposite is now 21. And that was the exact answer or rounded?
21.
It's exact. I'm glad they gave me an exact one. Over 29. Cosine is a piece of cake. Cosine already had the adjacent was 20. So adjacent over hypotenuse is 20 over 29. And tangent must be my opposite over adjacent, which is 20 over
Isn't it 21?
21. Yes. Yes, 21 over 20. Nice job, Steph. I really enjoy you in my class, Steph. And you're the one that seems to have the least self-esteem, and you shouldn't, because you are always on top of things. I'm going to cheat and just flip those. 29 over 21, 29 over 20, 20 over 21. I wasn't going to do this fourth one, but I think I need to because I have a missing side here. Wait, what side is that? Oh, so here's my shortcut version. If I take 6 square roots of 3, Luciano, and I square it, and I add it to 6 squared, then I take the square root of that, I'll have my answer. And I can do some of that in my head. Watch. 6 times 6 is 36. Square root of 3 times square root of 3 is just a 3. Plus 36. I'm going to take the square root of that. Now, I don't know if I want to do 36 times 3 in my head. I think it's 108. I don't know. 36 times 3?
12.
It's a 36 times 3 is 12?
36 times
Seems like
3
legit.
is 108.
I was right. So it's the square root of 108 plus 36. 36 plus 108 is how much?
Wait, 108 squared plus 36
No, I want 108 plus 36.
is 144.
Oh, I know the square root of 144. That's 12. Look at that. All right. I'm going to pick up the pace. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. Opposite of this angle here, is 6 square roots of 3. 6 square roots of 3 over 12. Could you reduce 6 and 12? You probably should. Make that into square root of 3 over 2. And the reciprocal is 2 over square roots of 3. Or I could have said 12. I could have said, well, either way, you're stuck. That turns into 2 square roots of 3 over 3 when I rationalize the denominator. All right, moving on. Cosine. Next to the theta is 6. 6 over 12. That's a half. What's the secant? 2. Tangent. Opposite over adjacent, that's going to be 6.
Isn't it 6 square root of 3?
It is, yes, 6. My thing stopped writing and I stopped talking. 6 square root of 3 over 6. That turns into what? Nice, she's good. What do I do when I flip square root of 3, guys?
1 over square root of 3.
She's right, but then I have to rationalize that real quick. You can do it.
Square root of 3 over 3.
Exactly, square root of 3 over 3. All right. Well, I did the whole first page. I wasn't going to do it all, but those are hard problems, so I wanted to get them done. Over here I want us to do. Let's see. It's more of the same, okay? 5 and 6, but they didn't give you a picture, guys. So let's look at 5. If he didn't give you a picture, you're going to have to say to yourself, if the tangent of theta is 7 over 24, that must be the opposite over the adjacent.
Yes.
Right?
Yeah.
I can draw my triangle now. Here's my right angle. Here is my theta. You can draw theta wherever you want as long as you don't put it on the right angle. Right, Luciano?
Yeah.
Yeah, what? What are you doing now?
Just,
A second phone?
no.
Okay. So this, what's opposite this way will be a 7. Do you agree? And what would the adjacent be? It would be where? On the bottom. Good. The bottom. What am I missing? So, I know it's going to be the square root. The hypotenuse is going to be the square root of 7 squared plus 24 squared. The answer is 25? Thank you. Then is 25. I only wrote down one part. That's enough work. You don't have to show all your work. That's enough work. Use your calculator. 25. I hope you agree with her. We have all the numbers I need now. Sine of theta, real quick. As fast as you can. Let me hear somebody.
something over something.
Oh my God, something over something. Wow, you're so correct.
7
It's
over
opposite.
25.
7 over 25. Yen, cosine of theta. She's asleep.
A really big number over 24 over 25.
Uh-oh. Luciano stole it from Yen. Yen, tangent of theta. She thinks I'm going to give up.
7 over 25.
Uh-huh, 7 over 20. Over 25. No.
24.
Oh, 24. Sin. Now, Fatima, cosecant. What's the answer? Right here.
25 over 7.
Perfect. Angel, secant.
25 over 24.
It is 25 over 24. Brandon, cotangent.
24 over 7.
It is 24 over 7. Nice. Well, I ran out of that. But I'll have to get her next. What time's the bell ring?
5 minutes.
5 minutes.
No?
No. You said 35?
15 minutes.
11:45.
It rings at 45.
45. No, let's do one more of these.
It's 11:30.
Let's jump over to number 8.
Sir, no, sir. It's 11:40. We got 15 minutes.
It's 11:25.
Well, yeah, but I want to make sure I do this bottom chart here. Let's do 8.
I know how to do that, sir. You want to do it?
Really?
I'll do it right now.
You're going to do it right now?
I'll do it right now.
Well, the average person can't do it right now. Because I don't know if you know what secant of theta means.
I don't.
If this is 4 over 1,
It's for A. Hypotenuse over the adjacent.
no. Secant is hypotenuse over, you're right. Oh, she's got it. So if I draw my triangle, put theta wherever angle of those two that I want. I'm going to trick you guys. I'm going to put theta up here.
That's so true.
So what's across the street from theta? Who am I going to pick on?
Valeria.
Okay, Valeria. What's across the street from theta right now? If this stands for, Steph said it was hypotenuse over adjacent.
Who knows what's across?
Wait, you want the
Nobody knows what's
number?
across.
Oh, nobody knows what's across.
One.
Not right now, right? Okay. So why don't I label what I have here? Where does the 4 go?
At the cross, the right angle.
Over here?
Yeah.
That's a 4. Where does the 1 go?
Probably on the other side.
Theta.
The leg that's up and down? 1. So now, let me help you out. To get this measurement, here's my shortcut. It's the square root of the hypotenuse, which is 4 squared, minus, not plus, because I'm missing a leg, minus 1 squared. Well, what is 4 squared? What's 1 squared? What's 16 minus 1? That becomes the square root of what? Square root of 15. I'm going to label this as square root of 15. Now we have everything. Was it extra work? Heck yeah. Was it hard? Yeah. Well, some of you say it's not, but I it's more harder than the average bear can do. So quickly, Gabriel, sine of theta.
Oh, snap. Square root of 15 over 4.
Does anybody disagree?
No.
Right.
All right. Valeria, what's cosecant then? What's the cosecant of this theta, if you already know sine? Say it again?
Yeah, you flip it. She doesn't know the number that you put. Like,
Square root of 15 over 4. It's the reciprocal, 4 over the square root of 15. But of course, we can't leave that answer. I have to multiply top and bottom by square root of 15. So that turns into 4 square roots of 15 over 15.
Wait, what?
Am I wrong?
Wait, what did you do?
I rationalized the denominator.
Oh,
yes, you're right there.
Okay. Cosine of theta. Who haven't I called? Yeah, you've answered a lot. No, Angel's answered. Yen's answered. In front of Yen. I haven't called him. You did? Then tell me the cosine of theta.
Took like all the questions.
But I never called on him.
1 over 4.
Yeah.
Luciano, you stole his thunder.
No, he said it, and I just said it louder.
You said it louder. Then, sir, finish it up. Only him. I want to hear his voice. Secant. It is. Nice. Alice, what's the tangent?
Square root of 15.
Are you sure? I thought it's going to be square root of 15 over 1. Oh, okay. Just kidding then. Alice, pick anybody.
I don't know what you're talking about.
I want to know the cotangent.
Well, 1 over square root of 15.
And that is true, but you'll make it better, right?
Wait, will you take that, will you take points away? If
I might take away a point.
It's square root of 15 or 15.
Square root of 15 over 15. It pays to know how to rationalize quick. Okay. Now,
We're done.
no, we're not. Here are two of the most important triangles in the world. And you have to memorize all of these values. Guys, it's real simple. Watch me. Watch. You did this in your geometry class. This is called a 30, 60, 90 triangle. It's one of your special ones. What are you doing? Before you leave, I want everything back on. Across the street from 30 is always a number 1. And then the hypotenuse will always be a number 2. Because it's the longest side. Then the third side remaining is always going to be a square root of 3. Always. Why? Go ahead and say if that's a 2. Watch this. If I want to find this side, the square root of the hypotenuse squared is 4, minus the 1. 4 minus 1 is 3. Square root of 3 has to be the other leg. So if you remember that across from 30 is always a 1, hypotenuse is always 2, you can always figure that out. But I want you to memorize, that's called a 1, 2, square root of 3. The 45, 45, 90 triangle. Since these two angles are the same, the two sides have to be the same. We'll give it a 1. 1, 1. And here's the icing on the cake. If you do Pythagorean theorem, you'll find out that this is the square root of 2. You want to do all Pythagorean theorems all the time? Go for it. I would suggest you just memorize these two triangles. So now, let's do the 30-degree angle all the way across. 30, again, these you got to memorize. Sine of 30 degrees would have been what? 1 over 2. Opposite over adjacent. Cosine would be? Square root of 3 over 2. Now the hard one, which I better make room for it, is what? Oh, you're going to look at the triangle. That's fine. What's that going to give you? 1 over square root of 3, but we'll make that into? Square root of 3 over 3. Now, how hard will it be to do the remaining 3?
Very hard.
Why?
You just flip
Oh, wait, he didn't yeah, he is asking for him. Flip what?
the sign.
So what's the cosecant of that theta of 30? 2. What's the secant of that?
2 over square root of 3.
Square root of 2.
She did all the work in her head. 2 square roots of 3 over 3. I love it. What does the cotangent give you?
Isn't it like the 3 over the square root of...
It's going to be 3 square roots of 3 over 3. Yeah, let me write it out because I'm not as good as you. We're taking 3 over the square root of 3. That turns into 3 square roots of 3, now over 3. And now the 3's cancel. The answer is just what she said, square root of 3, right? Equals the square root of 3. All right. 45 degrees comes from this triangle right here. What's the sine of one of those 45s? And pick either one. It doesn't matter. Pick this one. 1 over the square root of 2, but I'll change that to square root of 2 over 2. What's the cosine of that 45? It's the same answer, right? Square root of 3 over 2. Square root of 2 over 2, right. Square root of 2 over 2. What's the tangent of that? It is a 1. Opposite over adjacent. What, now just flip them all, right? So if I'm going to flip square root of 3 over 2, that looks like this. 2 over the square root of 3.
There's no
It's
three.
still, it's still two.
Oh, I keep saying 3. I don't know why. 2 over the square root of 2. That turns into 2 square roots of 2 over 2. But what cancels? The 2's. So just call it square root of 2. Secant flips what? Oh, it's the same. Yeah. Hello. Yeah. And cotangent is a 1, because if you flip a 1, it's still a 1. Good job, guys. Now we're on the last important angle that we have to know, 60 degrees. Now we're using this angle here. What's opposite of that 60?
I think it's square root of 3.
And what's its hypotenuse?
2.
There it is, square root of 3 over 2. What's the adjacent of that angle?
1.
Wait a minute. 1, and I got to go 1 over what? Wait a minute. I think you messed up on sine. No, you did it right. I messed up on sine. Okay, say it again. 1 over 2. What's the tangent? Square root of 3 over 1? So square root of 3. Yeah. Now we flip them all. Let's get the cosecant. 2 out of square root of 3 becomes. Say it again. 2 square root of 3 over 3. Absolutely correct. Flip the 1/2. Flip the square root of 3 over 1. Okay, for the average person, it's 1 over the square root of 3. When you rationalize, square root of 3 over 3. And I look at the next page, and you do have homework, and it's going to be all,
Oh, sorry.
both pages, but it's not due until when? It's written up on the board.
Tuesday.
I can't read.
Next time we meet. So
No, the next time you meet, you're taking a test.
Yeah, but you say we're gonna take this in next time.
No, you're not. Not the homework.
Oh, okay, just a minute.
You're gonna turn in the packet. You're gonna turn in all the lectures and the last homework we just graded. That homework does not have to be done
Okay.
until, when do I see you after the test?
Friday. Oh, I mean Thursday.
Thursday.
My bad.
So your homework will be due Thursday.
Wait, sir, it's front and back,
Say it again?
front and back.
Front and back. I need you to practice it well. Since we're not lecturing nothing new on test day, you still have 2 more nights to work on it.